All right, guys, we're back with another video on AP Calculus. Mr. Antonucci here, and in this one, I'm going to go over the 2021 AP Calculus AB Administration 1 free response question number 5. All right, so let's dive right in. Consider the function y equals f of x, whose curve is given by the equation 2y squared minus 6 equals y sine x for y greater than 0. They typically, in the stem of a problem, will give you all the information that you need, and all of it will be typically important at some point in the problem. So part A, they give you what the derivative is, and you have to basically show your work for how to do it. I think the reason they do that is because, one, they want to see if you can use the derivative rules to get the derivative, but also getting that step is necessary for a lot of the rest of the problem. So they want to make sure you have at least that. So part A, the derivative would be 2y dy dx. Derivative of 6 is 0. Equals, then we have to do product rule here. Derivative of y is dy dx. Remember, we're doing implicit differentiation here. Sine x, so derivative of the first times the second plus derivative of the second times the first, or the first times the derivative of the second. So we're doing implicit differentiation, and on the right-hand side, we're using the product rule there. So next, we want to collect our dy dx terms on the left side and factor out a dy dx. So dy dx is going to factor out of 4y minus sine x. So basically subtracted this to the left side and factored out a dy dx equals y cosine x. And then dy dx, just divide by that quantity, is y cosine x over 4y minus sine x. Again, this problem is no calculator allowed, so we won't even need to pull that bad boy in. So we're good there. Typically, since they gave you the answer, they're going to give you 1 or 2 points. They're going to probably want to see that you did implicit differentiation, use the product rule, and solve for dy dx correctly there. Okay, so B, write an equation for the tangent line to the curve at the point 0, 3. Well, not 3, square root 3. They already gave you your x and y. All right, sorry about that. Don't know what happened. My video just stopped. But carrying on, they gave you the point 0, square root 3, and your point is x, y. All right, and if you remember, for this, you're going to need to get the equation of the tangent line. You're going to need a point, and you're going to need the slope. So they gave you the point. The slope is the derivative evaluated at the point 0, square root 3. So we're going to plug that into the derivative. So root 3 cosine 0, 4 times root 3 minus sine of 0. Okay, cosine of 0 is 1. This is why it's important to know your unit circle, particularly the first quadrant, but you want to know the special trig values there. So cosine of 0 is 1 times root 3 gives you root 3. And then sine of 0 is 0, so you get 4 root 3, and so you get 1/4. The equation of the tangent line is y minus y1 equals the slope times x minus x1. And you could leave it like that, or you get y equals 1/4 x plus root 3. You don't really have to do that. So typically, they're going to give you a point for finding the slope and a point for finding the equation of the tangent line correctly. Bippity bop, bippity boop. All right, part C. For part C, it says for 0 to pi and y greater than 0. So that's important. First time I went through this one, I didn't catch that 0 to pi, and I goofed up. Find the coordinates at the point where the tangent line of the curve is horizontal. So it's going to be horizontal when dy dx equals 0, and that's equivalent to solving y cosine x equals 0. But if you remember, y has to be greater than 0. The only way this is going to be 0 is if y is 0 or cosine is 0. Okay? Y cannot be 0 because it's defined as being greater than 0. So that boils down to cosine x equals 0. That occurs on one cycle through the unit circle from at pi and 3 pi over 2. But our conditions say that x has to be between 0 and pi, so we don't need 3 pi over 2. So x equals pi is the x coordinate of the point where the tangent line, the curve, is horizontal. So we need the y coordinate, which we go back to the original equation, 2y squared minus 6 equals y sine x. X is pi over 2, so you plug that in. So you have 2y squared minus 6 equals y, and sine of pi over 2 is 1, so it becomes y. Then you have 2y squared minus y minus 6 equals 0. And we could use the quadratic formula if you want there. I'm just going to wave my hands over this and factor this just to show you what happens, or you could use the quadratic formula. Either way, you'll be fine. But for the sake of space and time, I'm just going to show you the factored form. You would get 2y plus 3 and y minus 2. Now this factor gives you y equals 2, and this factor gives you y equals negative 3/2. This would not count because, again, y has to be greater than 0. Now, if it did count, you would just have two coordinates. You would have pi over 2 comma negative 3/2 and pi over 2 comma 2. But since y has to be greater than 0, the point is pi over 2 comma 2. Bibbidi bop, bibbidi boop, we're done with that one. Okay, so part D, determine whether f has a relative minimum, a relative maximum, or neither for the point you found. Okay, so the easiest way I know to do this is with the second derivative test, because you already proved that the point pi over 2 comma 2 is a critical number. If your second derivative is negative, that means the function is concave down at a critical number, creating a relative max. If the second derivative is positive, that means the graph is concave up at that point, creating a relative min. If the second derivative is 0, well, then you definitely have to do the first derivative test. But oftentimes, the second derivative test is going to be helpful here. So what we want to do is take the second derivative, d squared, so this is part D, d squared y over dx squared. Now, the derivative, we're going to have to use the quotient rule. I always like to start this off by using the denominator or writing the denominator squared. One of the most common mistakes I see students do with the quotient rule is they forget to write the denominator. Okay, don't forget to write the denominator squared. Okay, so the derivative of the top is a product rule. So you have to be careful here. dy dx cosine x plus, well, it's going to end up being negative because the derivative of cosine is negative sine. So the derivative of the top is a product rule times the bottom, 4y minus sine x, minus the derivative of the bottom, so 4 dy dx. I'm running into this problem here. I should have put it a little lower. 4 dy dx minus cosine x, so derivative of the bottom times the top, y cosine x. Now, the second derivative, evaluated at the point pi over 2 comma 2. Some nice things happen here. In the denominator, you would have 4 times 2 is 8. Sine of pi over 2 is 1. So squared, you're going to end up with 49 down there. The numerator, you don't want to back substitute what the derivative is in terms of x and y here, because when you evaluate it to the point pi over 2 comma 2, the derivative you know is 0. You just prove that in part C. Okay? So we can use that fact. So this is going to be 0 here, and then you're going to end up with minus the y value, which is 2, sine of the x value, pi over 2, which is 1, times 4 times the y value, so that would be 8, minus sine of pi over 2, which is 1. Now minus here, 4 times dy dx is going to be 0. And then cosine of x is also cosine of pi over 2, which is also 0. So this whole entire term here becomes 0 because you would have 0 times whatever this value is. So that's going to be 0. So let's see what we simplify to here. We have 49. The numerator here, you would have -2 times 7, which is -14. That's less than 0. Okay, you don't even have to simplify it. So the question originally stated, determine whether f has a relative minimum, maximum, or neither found at the point found in part C. Well, also you have to justify your answer there. So since the second derivative is negative at that point, and that point is a critical number, we know we would have a relative max at that point. Okay, by using the second derivative test there. All right, guys, hope that was helpful to you in working out the solution to that problem. Make sure you check out my other videos where I go over the other 5 questions from this calc exam that have been released. Make sure you subscribe and hit the bell for notifications when new videos are uploaded. Hope that was helpful to you. Now take care.